Hello everyone. Today we will learn about the climatic regions of the world. Most students try to remember climate regions country by country. That fails. Climate does not care about national boundaries. It follows latitude, winds, relief, rainfall, and vegetation. So in this video, we move like a geographer, from the equator to the poles, from western margins to eastern margins, from coasts to continental interiors. Start with the most important correction. Climatic regions are defined by ecological factors, not political borders. The real controls are relief, temperature, rainfall, and natural vegetation. That is why a climatic region can cut across multiple countries, and one country can contain more than one climate type. Now hold two ideas together. First, ecological controls are relatively permanent. They change only over geological time, not with every political event. Second, climatic boundaries are fluid. They are not hard lines like international borders. They merge gradually. This is where most aspirants lose marks. They treat climate maps like atlas borders. Don't. Climate zones are transition belts, not wall-like divisions. Now begin at the equator. Between about 0 degrees and 10 degrees to 15 degrees north and south, you get the equatorial region. Its climate is simple and relentless, hot and humid throughout the year. Annual temperature range remains low, and seasonal contrast is minimal. That means there is no real winter-summer drama here. The atmosphere stays warm, moist, and active almost all year, and that directly affects life. Plant growth becomes rapid and luxuriant, but physical labor becomes exhausting because the human body struggles in constant heat plus humidity. So if a question gives you low annual range, year-round humidity, and dense vegetation potential, your answer should move straight to the equatorial belt. Move slightly away from the equator and the pattern changes. Between roughly 5 degrees and 20 degrees, especially in tropical continental interiors, you enter the tropical grasslands or savanna. This is where most aspirants get trapped because savanna is not simply hot grassland. It is a seasonal wind story. In summer, the zone comes under the influence of equatorial calms, so air rises and convectional rainfall occurs. In winter, trade winds dominate. These are dry winds and they bring drought. That is the whole logic. Wet summer, dry winter. Rainfall is moderate. Temperature range is broader than in the equatorial belt, and the region often lies in continental interiors, sometimes extending toward western sea margins. Do not memorize savanna as vegetation first. Understand the shifting wind mechanism first. Now move to the eastern sides of tropical continents, roughly between 10 degrees and 30 degrees, where you get tropical deciduous forests. This region has a clear seasonal rhythm. Summer is hot and wet. Winter is warm and dry. Rainfall is moderate overall, but it declines as you move away from coasts and mountainous tracts. That is the clue. This is not an all-year rainforest climate. It has a dry season strong enough to force vegetation to adapt. That is why these forests are deciduous rather than evergreen. Here's the distinction you must keep clean. Equatorial forest stays wet almost throughout the year. Tropical deciduous forest depends on a stronger seasonal rainfall pattern and a more noticeable dry period. Now go to the western sides of continents between about 20 degrees and 30 degrees, and you hit the tropical deserts. This is where UPSC loves testing causation. Do not answer deserts with, because they are hot. That is lazy geography. The real rule is the offshore wind rule. These regions lie in the trade wind belt on western margins, and the winds blow from land to sea, carrying almost no moisture. Rainfall is therefore extremely low, often below 25 centimeters annually. Temperature behavior is just as important. Because skies remain clear and cloudless, daytime heating is intense, and nighttime radiation loss is also intense. So the diurnal temperature range becomes exceptionally high. That is why hot deserts are not just hot. They are climates of intense dryness, offshore winds, and sharp day-night contrasts. Now shift to the eastern margins between about 20 degrees and 48 degrees, the China type region. This is one of the easiest regions to confuse unless you follow the seasonal wind logic. In summer, winds blow from the ocean toward the land. They are warm, moist, and bring moderate rainfall. In winter, the direction reverses. Winds blow from the interior landmass outward and they are cold and dry. That gives you a climate with wetter summers and drier winters. This is the exact opposite of the Mediterranean pattern you'll see next. So remember the comparison clearly. China type equals summer rain. Mediterranean equals winter rain. If you miss that contrast, UPSC can eliminate you with a single statement question. Now come to one of the most famous climatic anomalies in the world. The Mediterranean type, found mostly on the western margins between about 30 degrees and 40 degrees. This is where most aspirants lose marks. Why? Because unlike most regions, the Mediterranean gets its rain in winter, not in summer. In summer, prevailing trade wind influence and subtropical high pressure create hot, dry conditions, with winds effectively moving landward moisture away. In winter, the westerlies shift over the region. Moist winds from the ocean bring cyclonic rainfall, and the season becomes mild and rainy. That is the defining anomaly. Do not merely remember olive trees or vineyards. Remember the mechanism. Summer dryness, winter rain due to shifting westerlies. Now leave the margins and move into the mid-latitude interiors, where two different dryland outcomes appear: deserts and grasslands. First, the mid-latitude deserts, like Tibet and the Gobi. These usually lie in high plateaus or enclosed basins surrounded by mountains. The mountains block moist ocean air completely, so the interior stays dry. Because continentality is strong, you also get extreme summer-winter temperature differences. Then the mid-latitude grasslands. These receive more rainfall than deserts, but still not enough for dense forests. Rainfall is low, annual temperature range is high, and much of the rainfall comes through summer convection. Trees remain absent mainly because of cold winters and limited moisture. So here is the distinction. Both are interior climates, but one is drier and mountain-blocked, while the other has enough summer rain to support grasses. Now move to the higher latitude margins and compare two important types: West European and St. Lawrence. The West European type lies on the western margins in the permanent belt of westerlies. Think of places like Western Europe, the Northwest USA, southern Chile, and Tasmania. The key control here is constant maritime influence through westerly winds. The St. Lawrence type lies on the eastern margins, poleward of the China type region. Here, summers are warm and wet, but winters are cold and dry. The examples given include the northeastern USA, Canada, northern China, and northern Japan. This comparison matters because many aspirants remember both as temperate climates and stop there. That is not enough. You must separate west margin westerly dominated maritime climates from east margin continental influenced seasonal climates. Now comes the great coniferous belt, the taiga. This lies between the mid-latitude grasslands and the polar tundra. Its climate is severe. Winters are long, harsh, and snowbound. Rivers freeze. Snow can remain for months. Summers are short and cool, and that short summer is also when the region gets the peak of its moderate annual precipitation. The vegetation is equally distinctive. Softwood coniferous forests such as spruce, fir, and pine. This is not a broad-leaved forest world. It is a cold-adapted, needle-leaved forest belt, built for long winters and short growing seasons. If a question gives you conifers plus long winters plus short cool summers, you should move straight to taiga. Now step into the tundra, the polar lowlands. This is where one single word can solve a prelims question: permafrost. If the question mentions permafrost or a transitional zone leading toward eternal snow, that is your tundra clue. The logic is harsh and linear. Long, severe winters. Ground remains frozen year-round. Growing season becomes extremely short. Vegetation becomes sparse. That is why tundra is not simply cold land. It is a permafrost-controlled ecosystem with stunted vegetation and very limited biological productivity. This is a direct prelims clue. If you see permafrost, do not drift toward taiga or ice cap. Lock tundra immediately. Finally, the climatic extreme, the polar highlands or ice cap climate. Its core locations are Antarctica and Greenland. Here, the surface is covered by permanent ice caps. Temperature remains so low that even the summer highs do not exceed 10 degrees Celsius. Precipitation is also extremely low, and whatever little occurs is almost entirely in the form of winter snowfall. That means this is not simply a colder tundra. It is more extreme than tundra, more barren, and almost completely dominated by permanent ice. Keep the distinction clear. Tundra still has sparse vegetation and a short growing season. Ice cap is the world beyond that limit. Now compress the whole chapter into one mental map. At 0 degrees, think equatorial, hot and wet. Around 30 degrees margins, think split outcome. Deserts on the west, deciduous or seasonal humid types on the east. Between about 40 degrees and 60 degrees, think westerly controlled climates, including Mediterranean and West European patterns depending on margin and seasonality. And toward 90 degrees, think the polar world. Tundra first, then ice caps. This is the progression you must retain. Not isolated facts, not country names, not random vegetation labels. Map the winds and the climate falls into place. Map the latitude and the region becomes predictable. That is how serious aspirants revise the world climate and become exam ready.